The figure below shows a 6 by 6 grid partially filled with the numbers 1 through 6. How many ways are there to fill the rest of the grid with the numbers 1 through 6, such that each number appears exactly once in each row and each column? Alright, well, it's sort of like a Sudoku. Alright, you're trying to get the rows and columns to have the numbers 1 through 6 without any repeating numbers. And so it looks like we've got 1 through 6 across the top, 1 through 6 across the bottom, 1 through 6 down, and then 1 through 6 up the other side. Alright, first thing I'm going to do, I'm going to scroll down a bit and make this thing a little bigger so we can work with it easier. So let me stretch it out a bit. That'll make it easier. Alright, well, I probably want to look for the most restrictive cells first of all. So I want to look for the cells where there's the least possible number of numbers that can go in those cells. And if I look, for example, at this cell, alright, I want to have, I can't repeat numbers in columns or rows. So you can see we're restricted here. It can't be 3, it can't be 4, it can't be 2, it can't be 5. So this cell can only be 1 or 6. Okay, so we only have two choices. And then once we choose a number for this cell, we're restricted in these cells as well. Okay, because you can see these have the same issue. This one can't be 3 or 4 or 2 or 5, so it's restricted to 1 and 6. Okay, this one's restricted to 1 and 6, alright, because it can't be 3, 4 or 2, 5. And this one's restricted to 1 and 6. So once we choose a number for one of these cells, the rest of these cells are going to be just given, alright? So like for example, if we choose a 1 for this cell right here, then this has to be a 6. And this has to be a 6, and then this has to be a 1. So these four cells, these yellow cells, are linked together, and once we choose one number for one of the cells, all the rest of the cells will be restricted to, they'll be determined. And the same way, if, let me pick up another color here, for this is all symmetric. Oops, I want a highlighter. This is all symmetric, so we can see that these cells have the same issue. They can't be 3 or 4 or 2 or 5, right? So here's 2, 5, 3, 4. So this has to be 1 or 6. This has to be 1 or 6. This has to be 1 or 6. This one has to be 1 or 6. And once we choose a number for one of these, so if this is a 1, then this one has to be a 6. This one has to be a 6, and then this one has to be a 1. Alright, so there's really only two choices for this group of green cells. Alright, so the green cells are also linked together. And then we can, let's go to another color here. Let's take a look at these cells. Alright, so we know that the 1 and the 6 have to go here, right? In these cells, one of these cells. So the 1 or 6 are taken, and the 2 and 5 are taken. So now for these cells we're left with 3 and 4. Okay? In the same way over here, the 1 and 6 are going to be taken in the yellow cells, and the 2 and 5 are taken. So now this can only be 3 or 4. Alright? The same way down here, 3, 4, 3, 4. And again, these cells are all linked together. So once you choose a 3, say for example in this cell, then this one has to be a 4, this one has to be a 4, and then this one will be a 3. Okay, and if you choose a 4, then this will be a 3, and this will be a 3, and this will be a 4. Okay, so for the pink cells, there's also only two choices, and once we choose one number for one of the cells, the rest of them will just be determined, and we can fill them out. So then we have these cells here in the middle. All right, let me choose another color. And really, this is just again the same issue. You can see here that the 1 and 6 are going to be taken up in the yellow cells. The 3 and 4 are given on the outside, so we're left with 2 and 5. Okay? And again, in this column, we've got the 1 and 6 taken, we've got the 3 and 4 taken, so we're left with 2 and 5. Okay, so the same thing holds for these cells as well. So these orange cells are limited to 2 and 5, and once we choose one number in one of the orange cells, the rest of them will be determined, right? Because we can't repeat numbers in the rows or the columns. So if this is a 2, then this will be a 5, this will be a 5, and this will be a 2. Okay? So we have 2 choices for the orange cells. Alright, so let's take that and apply the fundamental principle of counting. Or you might know it as the product rule in combinatorics. Alright, so what we've got basically, if we look at the yellow cells, we have 2 choices for the yellow cells. We've got 2 choices for the pink cells. We got 2 choices for the green cells. And we have 2 choices for the orange cells. Okay, do you see that? So even though there's 4 cells, we basically have 2 ways to fill them out. Okay, it can either be 3, 4, 4, 3, or it can be 4, 3, 3, 4. Okay, so there's basically 2 ways to fill out each of these colored cells. So 2 ways to fill out the yellow, 2 ways to fill out the green, 2 ways to fill out the pink, and 2 ways to fill out the orange. Right? Those sets of 4 cells are all linked together. So when we multiply those choices together, we end up with 16 ways that we can fill out this grid. Alright, so there's your answer.